Mr. Victor from Tetra Tech, and the topic of his talk is unseen impacts of renewable energy integration and grid infrastructure interventions. Okay, Mr. Victor.
Now, thank you so much for the invitation to this webinar. I'm Victor Bedoya. I'm electrical engineer. Most of my background or my experience has been in the operation of power systems. And also in the last 4 years, I've been working on different projects as a consultant. I have had the opportunity to work in almost 10 countries around the world. So I want to share here some of the experiences that I have had in those countries with those projects. I want to share with you the knowledge that I have in this part, which is part of my passions, which is integrate the renewable energy to the power systems. So the idea here is basically we are going to talk about the integration of renewable energy in power systems, but at the same time, I want to highlight some aspects that sometimes we don't consider in the first stage when we are talking about renewables. Sometimes we start thinking about renewables like something that is going to be new for the grid, that it's going to bring a lot of benefits, a lot of improvements to the energy sector. But if we don't have that kind of exhaustive energy planning, this could be also a very big challenge in the future for the power system. So the idea here is that we have two perspectives of the integration of renewables in the power system. Then the first side, or the first perspective, will be the good things that we can have with the renewables, but also we want to see another perspective with the different challenges that we have seen in different projects around the world and different experiences with other countries. So that's the idea with this webinar. So let's proceed. Then with the unseen impact that we can have with the RE integration, we can also see that once we start evaluating those impacts in the network, we are going to come up with some solutions, right? So these kind of solutions are part of those plans that we have to solve all those challenges that we are going to have with the RE integration. So in this case, as I mentioned before, we are going to have a positive impact, let's say. In this positive impact, I think the major positive impact that we are going to consider here is the reduction of greenhouse gas emissions. That basically is to reduce the CO2 emissions. This is something that is aligned with all countries around the world, at least all countries that are part of the United Nations. They have that kind of climate goals, and this is a priority right now. I mean, global warming is a challenge right now for humanity. And in the power sector, we have this challenge right now. So the renewables, when we are talking about the wind projects or the solar projects, we also think that these are green technologies, and then the reduction of the CO2 emissions is very effective. So for this kind of aspect, I can say that this is the more, or this is the great impact, positive impact that we have from renewables. But we also have then that we can improve the grid reliability. We can have a very good amount of energy that it's going to be connected or integrated into the system, so we can get benefit from that kind of renewable integration. Also, increase the energy security. In some cases, when we integrate the renewable energy, we also are going to invest in the power network. So the idea is that everything that we are going to use as a complement for this renewable integration is going to improve, or is going to increase the energy security in the power grid. So this is something that we also have as a positive impact. In the social aspects, because we are having this boom right now with the integration of renewables, of course, we are also impacting the communities, and we are also impacting the job creation in countries. So this is also a positive impact that we have with the renewables. And reduced energy cost. As you may know, we have been using the fossil fuels for energy production for a lot of time. We know that that kind of energy is quite expensive. And if we compare with the renewables, basically the primary resource, like the wind and the solar irradiance, is for free, right? So this is going to lead that basically we are going to reduce the energy cost, and at the same time the materials that we are using for creating the solar panels and also the wind turbines are decreasing very fast. So this is also helping the integration of renewables into power systems. Then let's talk about the other perspective, that in this case are the challenges that we can also see with this renewable integration, right? So the first thing that I want to highlight here is the power system flexibility. With the power system flexibility is basically the system should be prepared to absorb the variability that we are going to have with the renewable energy, with this integration. As you may know, we have a lot of variation due to the different changes that we are going to have in the wind speed and also with the solar irradiance. Then the system should be flexible enough to absorb that kind of variations. If the system is not flexible enough, it means that you have to create, let's say, a market mechanism or a different, or you have to have a different strategy, right, to have that kind of flexibility and integrate the renewables in your system. So it's going to be like a balance. You are going to integrate the renewables, okay, you have to think also if the system is flexible enough for that kind of integration that you are thinking or that you are planning in your system. The second one, challenge is it's going to be the grid stability. Basically, these kind of technologies, in some cases, let's say for the solar generation, for solar PV, we are going to use a lot of inverters. So this is quite new if we think that we are going to use this in a massive way. So let's have another uh, perspective, that what's going to be the impact that we are going to have in the grid flexibility for all these new technology that we are incorporating into the network. So that will be the second bullet that I want to highlight here. Another thing is, in most of the countries, we are seeing that there there is a fast growing of DRE connection or the integration of small scale projects into the network. And in some countries, there's not regulation to integrate these kind of small generators into the network. The idea here is think on regulation, right? That will be another critical aspect that we have for this renewable integration. So what I want to highlight here is in most of the countries of most of the power system, they are, let's say, focused on the big amounts or in the largest generation, in this case for solar panels or for wind farms. But in the case that we're talking about small scale project, we don't have that kind of regulation. We don't have that kind of interest at the moment. And this is growing very fast. So somehow we need to continue improving the regulation for the larger generators, for those generators that in most of the country we consider that are larger than 20 megawatts. But at the same time, we need to start thinking and how is going to be control the integration of those distributed energy resources that are going to be in the network as small generators, right? So that's something that we need to talk here. That's going to be about regulation, okay? Another aspect that we can consider as a challenge will be the land use and the conflict that we can have when we are talking about those large projects, when we are talking about large integrations of wind power plant or solar power plant. We know that most of these projects require a huge amount of land. So in some cases, we have seen that in countries we are having some issues with the land use. So at the end could be also a conflict. So this is something that we need to highlight and think about it when we are talking about RE integration. Also, the social impact, how you're going to involve the local communities, how you're going to work together with the private companies, with the private investors, and also with the universities, and also with the different ethnical groups that you're going to have around the project or around this integration. That's something that we want to also highlight here. It's like how to integrate local communities, universities, private investors, all of them working for the same purpose, that would be an organized, well-prepared RE integration in a power system. And something that is quite new, that maybe can also have a lot of opportunities, new opportunities. We need also a lot of research in this topic, will be the material disposal. As you may know, let's say the first fleet of this renewable energy integration uh, was connected, let's say, between 25 and 30 years ago. Some of them are going to decommissioning, and then we have a new challenge right now that will be how it's going to be that process for material disposal. Okay, and this is going to be also an opportunity for different countries, and on start thinking about it and try to lead this challenge and try to create initiatives that are going to help the world and are going to help the RE integration in different countries around the world. Okay, let's talk about the power system flexibility. this time I want to share with you one of the examples, excuse me, that we have in Kaizo. What I brought this example here, it's basically because in Kaizo, we have, Kaizo is the ISO in California, in the US, is the independent system operator there. And basically they have a structure that it's going to be electricity market dependent. Uh, Basically, everything is integrated into the system based on competition between different technologies. And then with this kind of, let's say, structures in a power system, this is the trend that we are seeing for the operation of a power system. Then I want to highlight here that you can see here what's the amount of renewables that they are having right now in the network. You can also compare here that if we talk about the current demand, that could be around 22 gigs, uh, 18 gigs are coming, or in some periods can be uh, met by the renewables. So look at this strong trend that we are having in the power system, and with the integration of RE in this kind of markets, in this kind of systems, and then how they are dealing. If we use this as an example that we can have in our country, just to see what will be the future that maybe we could have in our system, then how they are dealing with these kind of different requirements that you have for that RE integration. Then in this case, they are also dealing with, for example, the decommissioning of coal power plants. Basically, coal, it's very unusual that we already have like a private investment on coal due to the different issues that we are having with climate change. We know that due to the COVID-19 and all those problems that we had with the different integration of generation around the world due to the COVID-19, then this came up again with some let's say integration or use of the coal as a source of generation. But we think that this is going to be for a short period, and at the end of the day, the coal, it's going to decrease every time his share in the power system as a source of energy generation. So these kind of technologies, you can see that the share to meet the demand is very low. Example was the coal, and also we can also see here that they have integration of batteries. So batteries are coming as a solution basically for this kind of RE integration. Then with the batteries, they are also trying to improve the reliability of the system and basically the flexibility of the system for these different ramps that they are going to experience, or that they are experiencing in the system, due to of course the variability and also the nature itself of the renewable generation. Then these kind of aspects are very relevant, very important for the flexibility, what it's around of this integration, what other technologies are they incorporating to improve the flexibility? In this case, the batteries is something that they are incorporating into the system to to deal with this specific issue. Also, the imports or the interconnections with other systems, with the central power system in the US, uh, it's also helping this kind of uh, increasing flexibility in the system. So, so this will be also another aspect that we want to highlight here, that another source of flexibility can be the integration with other systems, can be uh, that kind of import export that we are going to have with different areas and also with another countries. So this could be also an aspect that we want to highlight here. And another one, of course, that it's going to help on the power system flexibility, it's going to be incorporating complementary technologies that are going to help on those fast ramps that we are going to have in the system. In this case, they are also working um, with these natural gas engines, where basically they are taking advantage of these technologies and the fast response that they have in a power system to basically provide that kind of flexibility that is needed to incorporate the RE in the system. So that's basically the different technologies that they are using right now to incorporate flexibility in the system. Uh, Other technologies which are basically quite, let's say, rigid, could be, for example, the nuclear generation, that we know that the flexibility of these power plants is not is is still let's say under development. We are still or the engineering is still working to try to improve the flexibility or the speed of the different ramps that we can have with the nuclear generation. But at the moment, nuclear generation is a very effective generation to be on the load base, but to supply that kind of challenges or to provide a, let's say, effective solution with these kind of challenges with flexibilities, uh, they are still on the process. So this is basically the big picture that we are going to have in most of the power systems in the future. And yeah, that was the thing that I want to highlight here with this slide. So let's go to the grid stability and how we can incorporate new technologies into the system that are going to work as a complement for this RE integration. Then for this RE integration, then we are going to have basically different challenges on network congestion, voltage stability, frequency stability, and transient stability. In this case, there's something that came up in different power systems that it's basically to solve part of these problems. They are using new technologies, and these new technologies are based on this kind of equipments that that are considering inverters or this electronic power that we can incorporate into the power systems, and it can solve specific problems, and in sometimes it can help you to avoid the network expansion. Then I'm talking here with the flexible IC transmission system that could be, for example, for the STATCOMs that basically you can provide a different requirements of reactive power into the network. So in some aspects, you can, let's say, help in specific situations for specific contingencies. You can support the operation of the system, and then in this way, you can also replace the network expansion with these kind of new technologies. We can also see that the batteries for network congestion could be also a very good solution. So basically, the batteries can be charged during periods of low load, but and they can discharge or provide the energy during the peak load. So that will help us with the network congestion and also to solve the thermal limits. Uh, for the frequency stability, as I mentioned before, we are also incorporating a lot of inverters into the network. One of the challenges in some of the systems that we are having is basically when you integrate a lot of generation like PV solar panels into the system with inverters, because you don't have rotating machines for these generators, then you are losing inertia in these kind of systems. So this is something that we need to also discuss when we are talking about our integration, if we will need different uh, uh, synchronized compensators into the network to provide that kind of inertia that is needed in the system. And for the transient stability, whatever is needed to adjust the different technologies that we have for the power system stabilizers, and also for the automatic voltage regulators, and basically to improve the energy security in the system, and avoid that when we are having a large integration and different, let's say, interconnection with larger systems, uh, that we don't have any kind of issues, let's say, with power system oscillations and that kind of stuff. So these are different technologies that are also impacting the RE integration into the network, and also improving the different situations that we are having with the RE integration. Then also, I want to talk here about the regulation. It's something that we need to highlight here. I have basically 2 points that I want to highlight here. The first point, it's going to be all these small generators that we are connecting maybe in a non-controlled way into the network, that basically they are behind the meter in some of the houses, in some of the small business that we have in the cities, and and if we don't have a regulation that it's going to control the growing or the conditions and how these generators are going to be installed into the network, this is going to be a problem that the utilities are going to experience in the system. So this is something that I want to highlight here, that this is going to be a work that it's going to be with the utilities, it's going to involve the utilities and also the regulators in the country. And also the different requirements that are needed for the integration of REs. So it depends of the amount of the installed capacity that you're going to have with these RE integrations. What are going to be the conditions that you are going to have for the secure operation of all those generators? Then in this case, we want to highlight here the different conditions that you are going to have to keep the stability in voltage, and also to keep the stability in frequency. And in another way, other complementary, let's say, functionalities that are around this RE integration are basically, let's talk about how it's going to be the RE, the reactive power, uh, um, the reactive power generation, what's going to be the way to compensate the reactive power in the system, different things like the forecasting, how the generators are going to provide that forecasting to the network or to the system operator, and also what's going to be the strategy, who is going to provide the forecast. The forecast is going to be provided in a centralized way, or is going to be provided in a decentralized way. What are going to be the conditions that we are going to have from different projects to provide that forecast, and that information, it's going to, of course, improve the reliability and of the operation of the power systems. Also, the different conditions that we are going to have for control and supervision of the different REs that are going to be integrated in the system, and the testing process. With the land use and conflict that I mentioned before, basically in some countries, I'm talking about some in North America. I know that in Canada, they are working this kind of projects, but also in Germany, France, Sweden, Japan, they're also thinking in how to change a little bit the way that we are expanding the solar generation in the world. As you may know, this is taking a lot of amount of land, the expansion of this technology. So we are having here new developments that are now, let's say, in a testing mode, and basically is how we can save that space that is needed right now for this solar generation. So they are thinking on let's say vertical configuration of the solar panels. There are some challenges that they have to deal, or some challenges that we are going to have here with this technology due to the angles that we are going to have from the solar irradiance, what's going to be the efficiency that we are going to have with this kind of configuration. But my point here is I want that you also see that if some of the countries around the world are working on this, is because these will be part of the future, and these will be also a very good idea that you can have for the integration of universities and private investors, and how you can solve these kind of problems. Then this will be something that you can see as an opportunity for research, and how you can also be part of these solutions that the world are creating for these kind of problems in RE integration. Another thing was,
I'm sorry, Mr.
yes,
Victor. We are already behind the schedule. Could you speed up and finish
yeah,
maybe within 1 or 2 minutes? Thank you.
yes. Okay, thanks. Okay, and then with the social impact challenges, I want to show you here some experiences that we had in a project in Latin America. That basically, these are the types of problems that you can have when you are creating a wind farm project, a large wind farm project. So in that case, we experience these kind of challenges with the landscape and visual impact, uh, also with the property values. Uh, we need to work with the community, uh, basically to engage this community and let them know what are the different advantages that we are going to have for the integration of renewable energy. But also we have to be honest about the different challenges that we are going to have, and talk about the different compensation that the local communities are going to have for the integration of the renewable energy. If you don't have that kind of strategy with local communities, uh, the RE integration is going to be very, very difficult. If you have that kind of opposition from local communities, uh, that's not good for the project. So in these countries, we also had some support from USA to work with the local communities and engage them to the different projects. So at the end of the day, they can be part of this project. They can feel that the project is part of their communities, and also they are going to have benefits, different benefits from this kind of projects. So at the end of the day, they are going to support the integration of RE. So social impact, very important. The work that you are going to do with the local communities and how to engage the local communities. And this is my last slide. And basically, when we are talking about RE integration and the challenge that we are going to have with the decommissioning, I just want to leave here this example that basically most of the countries are start thinking about how to leave this kind of disposal of material. So in France, we already have one of the, let's say, recycling plants that are going to be focused on the decommissioning of these uh, photovoltaic panels, and basically the recycling process that we are going to have with this kind of material. I'm not saying that this is the only example around the world. We also have a lot of examples, but this is something new. So this is going to be an opportunity that we are going to have because this boom that we are going to have with the, or that we are having with the integration of renewables, at some point we are going, or we have to deal, and we have to be prepared also for the decommissioning of those power plants, and also let's say the connection of new technologies in the system. So that was all from my side. Sorry for taking a few more minutes, but I hope you enjoy the presentation.